the same. We just take this out. This is electric field. So actually the electric field E, as before, as we said now, before a moment, if it's changing, so we have to be careful about it. And then we now we are applying this example to see how can we deal with the changing electric field, okay? Now, it is given by this equation. You see now there is x here, a variable x. So the electric field equals to 2x in I direction. So this is one component of the electric field. And then we have the other component in k direction. But both of these components, okay, they are changing by x. So if it's x is 0, so we have the value 0 for E, okay? For instance, يعني إذا مثال خلينا مثال, if x is starting from 0 and then start to increase, that means the electric field will start to increase also. So the electric field is not constant. Oh, yeah. How can we deal with that? It would be easy, but we just see how can we make the things, add together by mathematical means. Calculate the flux. Okay, so we're looking also the flux of the electric field through that area S. Where is the area S? It's in the figure. You can see the figure here. Okay, we see that this is not a circular. Now it is like a square because we have the length is A. Let's say this is 0, and this is A also, the width. So the length is equal to the width. So all of these areas, see, this is a green shaded area. All of this area called S. Okay, and we know that we are not dealing with the plane area. We are dealing with the vector area. So we should draw, as we said. We said that it is represented with an area vector here. Okay. Now, it's the same thing. We have something called I and K. We know that X is for I notation. Okay. We know that this is for J, and this is represent what? Yes, I hear you. K. Excellent. Okay. So if it's in the XY plane, you see the area now again, it's in the XY plane. Okay, it's in the XY plane. So all the lines, اسمعوني شباب مركزين معي, all the lines that are moving, okay, toward X, which is 2X, this one, this part here. Okay. All lines here, they will go parallel with the plane. So they will not penetrate. ما راح تخترق المساحة لأن الفيض شروطه خطوط تخترق مساحة. Okay. So if there are no penetration, there are no lines are going through that surface, so we are not looking for the flux, electric flux. So now, how can we deal with this one? Don't forget to write that electric field is not uniform. Okay, let me change the color here. Okay. So electric field is not uniform. Okay. يعني changing يعني مختلف. Okay. In this case, we should ask ourselves, how can we make all of these E? How can we add? Okay. Adding all of E's. We have a mathematical calculus, a way of doing that. We call it integration. Okay. So we need to integrate, to add. يعني كلمة integration هذه البعض ما فاهمها تعني يعني summation جمع بس. Okay. So I want to add all of these portion of that E when x equal to 0, when x equal to 0.1, 0.2, 0.3, up to the maximum, which is A here. Okay. Because now we are looking for flux, and flux actually is the number of that lines penetrating the area only. يعني ما حد يكلمني على منطقة هنا أو منطقة هنا. We are not looking of all of these, outside area. We are looking only of that shaded area. So in this case, we should know and consider that area only. Okay? And how can we add this area? We know that we can make small area, differential area, we call it. Okay? Let's take this area, any kind of area, any kind small area. We will make this large area, S area, into a very small differential area. We call it delta A, but it's actually made of delta X because we are moving in X. Okay, and the width of that, or the length in this case, is A. You can see يعني هي عندها الطول A لكنه العرض مالها dx صغيرة جدا. So if I can add all of these small portions or differential area, this area, I mean this shaded area with red here now. Okay, if I can add all of them here, so then I have the other one there and the other one all the way from 0 to A. So that means I'm adding all area. Oh, so in this case now I'm adding areas as well as adding the electric field. Okay, so in both cases. Okay, my dear students, how can we do that? It's very easy. Let's first of all see, okay, what is dA? Okay, what is dA? dA actually, as I told you just now, it's just multiplication of, students? I heard
A multiplied dx.
Excellent. dx into A. That's right. That's right. Why is that? Because it is clear that this is the smallest area. We have it there. Excellent. Excellent. So we need only to substitute instead of delta A, we put it here. Okay. And also keep in mind that this is also changing. So we should take only the changing part that affect our work. Which one is changing now? I mean, which one will take? Actually, we'll take the K direction, electric field. Why we take this direction? Because as we said, only these lines can penetrate. And if it's penetrate, so then we can get the electric flux.
The angle is 0.
Okay, yes, the angle is 0. Excellent. MashaAllah. Right. Now let's calculate phi. So phi is just, as we said, we can write it all. We can write this is the x component of the electric field, I mean in the I direction, okay, plus the other way, which is the K direction of the component of the electric field. We can also ignore this one. يعني احنا بإمكاننا نلغي هذا، ما لازم نكتبه يعني مثل ما عملنا في المرة الأولى. Okay, we can add hat here for this direction, and then we don't forget that this is also multiplied with dA, and we know dA is just dx into A. That's very easy. Okay. Until now, everything is clear? Okay. Don't forget that this direction, it should be also in the direction of K, because we wrote that this area is just a vector and it has direction. Okay. So we have K here and we have K here, so we deal only with these two, okay, together. And this will give us, okay, we can just simplify it as the, you know everything here, but just make things very good. And we make A outside because A is constant, okay? And if you have like a very normal and direct way of integration, 3x squared A dx, we want to integrate this one, okay? أنا أسمع واقرين الحين يزعقوا من داخل هناك وفي عقولهم يعني سماع مجازي. This one will be 3x to the power 3 over 3, yes. But we are integrating, as we said, from 0 to A. We should write this one here, 0 to A. So this square bracket is the integration only of this part. And don't forget we have A here. Why we make A outside? Because A is constant. You can also take 3 outside, actually. And both of them are constant. Okay. But because the result of the integration, okay, gives us at the denominator 3, so then we can take 3 with 3 out. So at the end of the day, actually this one it should be written like, يعني أنا راح أكتبها الحين بس هي not necessary يعني. هذه أصلا تساوي A into, okay, A to power 3, yeah, minus A into 0 to the power 3. Yeah, you have to, from 0 to A, you start with A, put it there, substitute instead of X, and then you get, at the end of the day, this will equals to A to the power 4. But this is, as you know, this is what? This is flux, electric flux. So this will be Newton per coulomb into meter square. Okay. دائما لما تحله وتنسى اليونت او تروح عليك هاف مارك وبعدين تقول لي وين راحت، هذه لا تنساها في الفيزيكس دائما. So this is the electric flux. Until now, we solved now two